Good morning, class. Today we are continuing on section 6.4 in your E-Maths, and that is the cosine rule. This can be found on page 197 of your textbook. Page 197 of your textbook. Now, after you have done with page 197, can you please turn to page 199? Now, you will see in the box, there are many formulas down there. Now, there's no need to memorize all of them. I just want you to know one of them, and you can use that to derive all the others. Okay, now I'm going to go on to how to use the formula. Okay, can you all please turn to page 199? Okay, now I'm going to show you a triangle first. Okay, now I've already told you how to name the sides according to the triangle. If this is big A, this is little a, this is big B, this is little b, this is big C, this will be little c. Now, for cosine rule to take place, I need to know this side and the included angle. Okay, we need to know two sides and the included angle. Included angle means the angle is sandwiched between the two sides. Then we can find this side here that's opposite the included angle. Therefore, you only need to memorize this particular formula. C square is equals to A square plus B square minus 2AB cosine C. Now, it's very easy to remember. C square is A square plus B square minus 2AB cosine C. Note that the side over here and the angle over here must be opposite each other before you can apply the cosine rule. Okay? Now, some people will say, can I use the cosine rule in a right-angled triangle? I'm going to show you in the next part that it is not necessary. Now, for example, if I have a right-angled triangle like this, okay, and you want to apply the cosine rule, okay, if you are applying the cosine rule, you will have this particular situation. This is the side opposite it, so it's AB square is 3 square plus 4 square minus 2AB cosine C. Now, cosine 90 is actually 0. If you press the calculator, you will get 0. Then you will get this. That means you will get AB square is equals to 3 square plus 4 square. Now, realize that this is actually the Pythagoras theorem. Okay, so you will get the answer as 5 cm. That's why before I start sine rule, I already told you that for right-angled triangle, there's no need to use cosine rule and sine rule. For right-angled triangles, you just need to use Pythagoras theorem and Tuakaso to solve the questions. But if you want to use sine rule and cosine rule, you are not wrong, just that it's very tedious. Okay, now I am moving on to example 9 to show you how we can apply the formulas. Okay, now let's take a look at example 9. Now this one looks a chunk-full, but don't worry, I'm going to go through part by part with you. Now, can we look at the diagram first? Let us all look at the diagram. Okay, the question in part 1 says the length of AB. They want to find the length of AB here, AB. Now, realize that AB is opposite 67, and these two are knowns. So, we apply the cosine rule here. AB square is 10.4 square plus 8.8 square minus 2, 10.4, 8.8, cosine 67 degrees. Okay, cosine 67 degrees. Then after that, you just need to take the square root and give the answer to 10.7 cm. To 10.7 cm. Okay, now next, we are going on to part 2. Part 2 asks you to find angle ABC. Now, I want you to look at the diagram. ABC is this angle that I've shaded. Okay, now I can use sine rule. Sine of this over this is sine of this over this. Now, don't forget, if you're using this as working, it has got to be 5-figure truncate. Okay, now then I do the basic angle that we have done so far, and we realize that because sine is positive, I will get two answers, one acute and one obtuse. Okay, now we will have two, and we'll realize the obtuse one is rejected. Now I'll explain to you why the obtuse one is rejected. Now, can you see that this and this are opposite, and this length is longer than this? Therefore, I only have one answer here, like when I've explained in the sine rule. Okay, I repeat, this is shorter than this, so there's only one value here. Alternatively, you can use the obtuse angle and you plus 67 degrees. It will already exceed the 180 degrees that is angle sum of triangle. Okay, even when we haven't considered the third angle. So this answer is rejected. So if angle ABC is 63.7, for the last part whereby you need to find angle BAC, we just have to use the answer 63.684 to get 49.3. Okay, 49.3. Okay, so the red part here is to part 1, the blue one is to part 2, and the green one here shows you part 3 of example 9. Okay, so I hope you are clear with this particular question. Now, I am moving on to example 10. Okay, the reason why I said you do not have to memorize all the formula is because it is very easy to just manipulate the formula by knowing one of them. Okay, now in example 10, the question says to find the size of the smallest angle. Now I already told you the smallest angle will be opposite the shortest side, and the biggest angle will be opposite the longest side. So you can see that 8 cm is the shortest side, and I'm supposed to find this angle here. That is your angle A. Okay, now you are given all the three sides, and you know that 8 is opposite A. So we apply the cosine rule. 8 square is equals to 9 square plus 12 square minus 2, 9, 12 cosine A. Now make sure you check that this side and this angle are opposite to each other. Okay, then how do I do the manipulation later? Now I'm going to show you. Okay, now first, this is negative, you bring over here, it becomes positive. This one stays here, you bring the 8 square over, it becomes negative. Okay, then you leave the cosine A over, you bring this one over, become divide, you will get this answer. So you key in the inverse cosine, you will get 41.8. Now let me just tell you that for cosine, you do not have to worry about whether is it acute or obtuse, because for cosine, remember this rule, over here cosine is positive, over here cosine is negative. So this side cosine is positive, this side cosine is negative, so there will be no confusion. There's only one answer. If it's positive, it's acute. If it's negative, it's obtuse. That's all. It's unlike sine, where we have both acute and obtuse being positive. Okay, so there's no need to worry about cosine, because over this side cosine is positive and we have only one answer, and when cosine is negative we have only one answer over this side at the obtuse side. Okay, so for cosine there is no need to worry. Now I'm going to repeat this. For sine we have two answers, acute and obtuse, but for cosine, when cosine is positive, I only have one answer because it can only be the acute angle. If cosine is negative, I will only have one answer, which is the obtuse angle. It is very clear cut. There is no two answers. There is only one answer. Okay, so this is your example 10. Alright, now next, I'm going to give you the homework that is on exercise 6D, and this time round there are only 5 questions to be done on the foolscap paper, and please check the next section only after you have done your homework. Okay, now I'm straight away going to question 5. Okay, question 5. This is the answer to question number 5. Okay, question number 5 requires you to find the size of the smallest angle, and the size of the smallest angle will be the angle that is opposite the shortest side, which in this case is A. Now make sure this and this are opposite each other, and then you do the necessary calculation. You bring this negative over to become positive, and you bring this 3.8 over. After that you divide, find the answer, and this will be the answer. Like what I've said just now, there will be only one answer, because when cosine is positive, the angle is acute. Okay, now I'm going on to the next one, that is question number 7. Question number 7. Now for question number 7, okay, let's take a look at the diagram. Okay, let's take a look at the diagram. Now, all of us, maybe most of us, will start with the sine rule and realize that CD is 9 meters. But if you can see that this is 55 degrees, and according to adjacent angles on straight line, this is also 55, it makes this a isosceles triangle, which I can conclude that these two sides is 9 meters. So whether you use this or this, the answer will be the same. It's 9 meters. Okay, 9 meters over here. Alright, now part 2, the length of AD. Now, I'm using the cosine rule here, and I can find the length of AD easily by making sure that AD is opposite. AD is opposite 125. Now, for this particular formula, I'm actually looking at this triangle. That's why I have 8 square plus 9 square minus 289 cosine 125 degrees. I'm looking at the triangle that I've highlighted for you in blue. Okay, so that will be your question number 7. Now, I'm moving on to question number 11. Okay, 11 is a short question. Let's look at 11. It says to find the value of A and theta. Now, let's find the value of A. Now, to find the value of A, I'm actually applying cosine rule, which I think most of you will not have problem. You just substitute in, you get your A as 7.94. Okay, 7.94, which means I am actually looking at this particular triangle. Sorry, I am looking at this particular triangle, the one that I have shaded. Okay, the one that I have shaded. I'm looking at this particular triangle. Now, for part 2, when you want to find theta, okay, when you want to find theta, then I am looking at this triangle, the triangle over here. Because we found A is opposite theta, I will substitute in, and I do the necessary manipulation. I will get cosine theta, and after that, can you just look up here? This will be the final answer for theta. Okay, so I repeat, for part A, you look at this triangle here on top, and for part B, you look at this triangle here below. Alright, so this will be the answer to question 11. Alright, I'm going on to question number 13. Question number 13. Now, question 13 is actually a scale, sort of a similar triangle question, and it's based on scale. Okay, but not to worry so much. For part A, they ask you for the length in kilometers, which is represented by xy, represented by xy. So we do the necessary manipulation and we will get 20 kilometers. Okay, 20 kilometers. Then part 2, they want angle YXZ. Now they want angle YXZ, so I do the necessary calculations using the cosine rule. I will be able to get the answer. Using the necessary calculations using the cosine rule, I will get the answer. Now some people will be asking me, if I use this ratio, this length and the real length, would it make a difference? It will not make a difference, because the two triangles, whether is it on the map or on the real ground, they are actually similar, and therefore when you take sine, cosine and tangent, they are actually the same. It doesn't matter whether you take the one that is on the map or on the real ground, because the answers will be the same. Okay, just that one is smaller and one is bigger, but the angle must be the same. If the angle is not the same, then they cannot be similar. Okay, so this is part 2. So I repeat, you can either take 9, 8, 12, or you take the originals, the one that's on the ground itself is 20, so on and so forth. After you have calculated, it's fine. Okay, they are the same. Now for part 3, the area in kilometers square, which is represented by triangle XYZ. Now we have already found this angle, and we know that this side represents 20 kilometers according to part 1. Okay, so I just have to find this one is represented by how many kilometers in real life, that means on the ground. So I'm going to find, and we realize that 9 cm is actually 22.5 kilometers on the ground. So I apply, remember our area of triangle is half AB sine C. Remember this one? Two sides and an included angle. So I'm going to apply area of triangle, half AB sine C, and I will get the answer as 225 kilometers square. 225 kilometers square. Now class, after you have learned a new thing, you must not forget what you have learned previously. This was done in section 6.2, whereby we have area of triangle is half AB sine C. So all this must not be taken in isolation, but you should lump them all together so that you can apply them effectively. Okay, now I'm going on to the last question, which is question number 17. Now this is at the advanced level, it's not very advanced. Okay, I will show you why. Now first, they give you all the information, and then they ask you to find the length of PQ. Okay, they ask you to find the length of PQ. Alright, now my aim here is to find this angle first. Okay, to find this angle, I make use of this big triangle. I know this side is 8, this side is 13. Alright, so I will apply cosine rule. I will get the answer, and angle A is 79.753 degrees. Okay, now after I have found this angle, I can find PQ by looking at this triangle APQ, the smaller one. I'm still applying cosine rule, okay, using the smaller triangle, and I will be able to get the length of PQ. Okay, alright. Now, in summary, for cosine rule, let me just summarize over here for you. You can find this side, given this side, and an included angle. you can find this unknown side using cosine rule. Okay, or if you are given any three sides, you can find any angle. For example, if you want to find this angle, okay, you just have to take this one as the opposite. That means if I want to find this angle, let's say this angle is x, I will have a square equals to b square plus c square minus 2bc cosine x. Then I will be able to plug in the values because I already know a, b and c, and I'm finding out x. Okay, you just have to ensure that this side and this angle, they are opposite to each other. So for cosine rule, you either find an unknown angle given three sides, or you find an unknown side given given two sides and one included angle. You are able to use the cosine rule to solve the problem. Okay, so class, this will conclude the section on cosine rule. Please read through again and go through the video again if you are not sure of what I am saying. Thank you, class.